Guidonia airfield near Rome, June 1943. Chief Engineer Filippo Zapata wiped his brow and walked a slow circle around the guarded airplane parked in the sun. The twin-boom American fighter shone under the Mediterranean light, its bare aluminum almost flawless, only a few scrapes from an emergency landing in Sardinia 3 days earlier. A simple navigation mistake had delivered a technological prize straight into Italian hands. It was a Lockheed P-38G Lightning, intact from nose to tail, with both Allison engines still warm from the hop north. When Zapata first saw it on the ramp, his instinct matched that of every Italian pilot he knew. The thing looked wrong. 2 long booms flanking a slim central nacelle violated every rule of graceful Italian design. His colleagues nicknamed it Il Diavolo, a due code, the twin-tailed devil, spoken with more sarcasm than fear. But once Zapata began a systematic inspection, the numbers man in him ran headlong into an unwelcome conclusion. The Lightning wasn't awkward at all. It was prophetic, and its hardware offered a mathematical proof that Italy had already lost a war its leaders still imagined they could win. Zapata served as the Regia Aeronautica's senior propulsion engineer, with 15 years designing and evaluating power plants for Fiat, Alfa Romeo, and Asata Frascini. He had pored over captured British Spitfires, studied Soviet Yaks, and analyzed German machines. He believed he understood where aviation stood in 1943. He was about to learn he didn't. As his team approached the P-38 with toolkits and gauges, a sense of dread pressed on him. The Americans had ferried this machine across an ocean to fight a war thousands of miles from home. That fact alone hinted at an industrial muscle Italy could scarcely grasp. Yet what hid beneath those cowlings would deliver a deeper shock, one that would haunt Italian aeronautical engineers for the rest of the conflict. They weren't just behind, they were outclassed, beyond reach. The Lightning embodied everything Italian fighters were not. Where Italian designs chased elegance and lightness, squeezing performance from minimal material, the American fighter was big, intricate, and powered by engine technology Italian factories could not hope to duplicate. Zapata knew the headline specs by rumor: twin Allison V-1710s, turbocharged, counter-rotating propellers, tricycle gear. On paper, it looked indulgent. 2 engines where one should do. Layers of complexity. Classic American excess. Or so it seemed. But Zapata was a scientist. Reputation meant nothing without measurements. For the first hour, they did nothing but record exterior dimensions. A 52-foot wingspan. Reasonable for a fighter. Then they estimated loaded weight from structure and fuel capacity. And the figures hit like a blow. Nearly 18,000 pounds at full load, almost double Italy's frontline Machi C-202 and Fiat G55. "How does something this heavy even get off the ground?" muttered his assistant Giorgio Mancini, noting the numbers. "That's what we're here to learn," Zapata said, though he already feared the answer. The real work began when they pulled the cowlings. They opened the port side first. When the panels swung free and the Allison V-1710-49 lay exposed, the team fell quiet. It wasn't the sheer size, though a liquid-cooled 12-cylinder V looked enormous by Italian standards. It wasn't even the jewel-like machining, though every surface told of precision beyond what bombed-out, material-starved Italian plants could deliver. It was the turbocharger installation. Zapata had read reports about U.S. turbochargers. The idea itself was old, Use exhaust to spin a turbine that compresses intake air and keeps sea-level power at altitude. German engineers had trialed it. Italians had sketched proposals, but no one, neither Germans nor British, and certainly not Italians, had truly integrated a turbocharger into a volume-built fighter. The Americans had done it twice on the same plane, one system per engine, and they were turning out hundreds each month. The turbo sat aft and low behind each power plant, fed by exhaust ducting that wound through the tail boom. Examining the turbine wheel, Zapata saw metallurgy mastery, a forged piece intended to spin past 21,000 RPM while bathing in exhaust over 700 degrees east. "What alloy is this?" Mancini asked, touching a blade's edge. Zapata shook his head. "Nickel chrome, perhaps. Maybe something proprietary. Whatever it is, we don't have it. And if we source the metal, we still lack the casting precision to make this part." The implications were brutal. With turbo and supercharging, each P-38 engine could deliver about 1,125 horsepower in war emergency power, over 2,150 combined. By comparison, the Daimler-Benz DB605 powering the latest Machi C205V, Italy's top single-engine fighter, produced roughly 1,475 horsepower. One Lightning carried nearly twice the power of Italy's best single-engine machine, and the arithmetic kept getting worse. Zapata began running the totals. The V-1710 displaced 1,010 cubic inches, 28 liters. To build such a motor required the flawless machining of 12 cylinders and pistons, robust rods, a crankshaft happy at 3,000 RPM under combat loads, plus the engine-driven supercharger, the exhaust-driven turbo, intercoolers, oil coolers, radiators, and reduction gear. He opened his notebook and started a parts ledger. Mancini watched, then voiced the thought both men shared. "Could we build this?" Zapata kept writing before he answered. "One? Perhaps. Give us 6 months, unlimited budget, our best machinists, and ideal conditions. Build it to run reliably, unlikely, produce hundreds, impossible." Even the cooling layout taught lessons. The Allison used liquid cooling with remote radiators in the wing leading edges. Low drag, high efficiency. Those radiator cores were tidy miracles. Hundreds of fine tubes, each brazed within tight tolerances to prevent leaks while shedding heat. Italian radiators were heavier, less efficient, and more fragile under fire. The American layout added armor, redundant coolant passages, and a glycol mix that ran at temperatures Italian systems couldn't tolerate. "They solved problems we didn't know we had," Mancini said, tracing lines with a fingertip. "They solved problems we knew about, but couldn't afford to fix," Zapata replied. The counter-rotating props were another layer. The left engine turned clockwise, the right counterclockwise, canceling torque that plagued single-engine types. That demanded mirror image reduction gears, different governors, careful synchronization. Zapata inspected the reduction unit, a dense, exact gearbox stepping engine speed down from 3,000 RPM to roughly 1,400 at the shaft. The gear teeth were hardened and ground to thousandths of an inch. "We can't make gears like this," said metallurgy specialist Domenico Russo flatly. "Not with our steel, not with our heat treat. These must carry Possett's down 500 horsepower without stripping. Ours would fail at half." A pattern emerged, more chilling than any single part. Every system in the P-38 seemed built for redundancy, maintainability, and operational flexibility. The electrical network was 24-volt with 2 generators, one per engine. If one died, the other kept essentials alive. Italian fighters used 12-volt systems with a single generator. The hydraulics that ran gear, flaps, and dive brakes had redundant pumps and multiple circuit breakers. Italian types relied on mechanical linkages or single-point hydraulics that a single hit could cripple. The fuel system had self-sealing tanks, still novel in Italy, and a clever cross-feed that let the pilot move fuel between tanks or run on one engine to save the other. But it was the armament load that truly stunned the Italians. A 20mm Hispano with 150 rounds, plus 4 Browning 50s with 500 rounds each, all grouped in the nose, 1 cannon, and 2,000 heavy machine gun rounds. No convergence guesswork. The Machi C205 Vaffi carried 2 12.7mm guns with 400 rounds and a 20mm with 200. The Lightning held roughly triple the ammunition and hit far harder. "They built a flying gun platform," Mancini said, studying the feeds. "Look at these chutes and boosters, designed to run under high G without a hiccup. Those electric feed motors keep the belts moving, even at 6 Gs. Zapata's pencil flew, but he had stopped listing specs. He was calculating production burden. A single P-38 demanded on the order of 50,000 individual parts. Each engine contained more than 6,000 pieces. The electrical looms ran to 8 miles of wire. Hydraulic valves and seals needed precision that Italian suppliers could not promise. The alloy airframe required aluminum grades Italy struggled to source under blockade. He looked up at the Lightning and, for the first time in his career, felt true despair. This was not merely an enemy airplane. It was evidence of an industrial revolution that had left Italy on the platform as the train pulled away. That evening, back at his desk in Guidonia, Zapata started his report. The technical section ran 12 pages, measurements, materials, performance estimates, but the last part, strategic assessment, would draw fire. He wrote, "The Lockheed P-38 Lightning reflects an aeronautical sophistication beyond current Italian manufacturing by approximately 5 to 7 years at our present pace. More important, it demonstrates American industry operating at a scale we cannot approach. Specifics: the turbocharged Allison V-1710s yields roughly 1,125 HP with superior altitude performance. Italian industry lacks the metallurgy, precision machining, and quality control to replicate this power plant. Producing a single prototype might require 18 months and consume resources equivalent to 20 conventional fighters. The turbocharger alone depends on materials, precision casting, and high-temperature metallurgy we do not possess. The counter-rotation gear train removes torque, but demands reduction gears we cannot make reliably. Airframe alloy quality and forming exceed our standards. System integration, electrical, hydraulic, fuel, armament, prioritizes redundancy and maintainability rather than weight savings, an approach enabled by engines strong enough to carry the penalty. U.S. factories appear capable of building these complex aircraft in quantity while holding quality. Intelligence indicates monthly production above 200 units at multiple plants. Italy's total fighter output across all types averages about 150 per month and is falling under shortages and bombing. Recommendation: we cannot counter the P-38 through technological parity. Italian fighters lack the engine power, high-altitude performance, and firepower necessary to engage effectively. Tactics should minimize contact with P-38s. Strategic view: if this type represents standard American output, and available intelligence says it does, Italy faces an enemy with overwhelming industrial superiority. A war of attrition against such capacity cannot be won. He read the document 3 times and signed. He knew what would follow. The technical pages would pass. The strategic warning would be dismissed as defeatism. But he was an engineer bound to evidence, and the evidence was unforgiving. Next morning, Colonel Angelo Tandi, the Regia Aeronautica's chief test pilot, arrived to fly the captured Lightning. A veteran with thousands of hours in dozens of types, he had flown every Italian fighter, plus captured Spitfires and a Messerschmitt Bf-109. He listened to Zapata's briefing with professional courtesy and a skeptical look that said the engineer was overselling it. Americans built heavy airplanes, everyone knew that. Quantity over quality, brute force over grace. Tandi climbed into the cockpit with the assurance of a man who had mastered every machine he touched. From the tower, Zapata watched the start sequence. Left engine, then right. The twin V-1710s settled into a smooth, synchronized rumble that rattled windows. Tandi taxied out, cautiously learning the tricycle gear and nose wheel steering. The takeoff roll looked long to eyes used to Italian fighters that leapt skyward, but when the Lightning rotated, it climbed at an angle that snatched the breath from Zapata's chest. 15 minutes later, Tandi landed, taxied in, and shut down. He sat for a while, then climbed down. His face had changed. He walked straight to Zapata. "Your report is accurate," he said quietly, "and you even undersold it. At altitude, this thing is untouchable. At 25,000 feet, it was still gathering speed. I've never seen a climb rate like it. The controls are heavy but precise. Visibility is excellent. The guns—" He paused. "I fired a short burst. It's like throwing thunder. Cannon and 450s all up front. No convergence games. You point, you shoot, it kills." "Can we counter it?" Zapata asked. Tandi thought a long moment. "Not with anything we have, not with anything on the boards. The C-205V is superb at medium altitude. The G-55 hits hard. Neither can match this at the heights where modern fights happen. High altitude, high speed, long endurance. And if they really build these at scale? Estimates say 500 a month by late 43. Tandi gave a laugh without joy. 500! We build, 50 Mach-Es and 30 Fiats in a good month? And they're also rolling out B-17s, B-24s, P-47s, P-51s, ships, tanks, everything. We're fighting a nation that can put 2 100-plus horsepower turbocharged engines in one fighter and still make hundreds." He glanced back at the Lightning. "What does that tell you about the war?" Zapata had no answer. The question didn't need one. In the weeks that followed, Italian engineers wrung the P-38 out. They flew it against Italian types across altitudes and speeds, timed climbs and dives, measured turn behavior, and benchmarked systems against Italian and German peers. Every trial echoed the same grim verdict. Above 20,000 feet, the altitude of bomber interception, nothing Italy flew could catch it. The turbochargers kept full power where Italian engines starved for air. Even the Bf-109G, with its DB-605, lost much of its edge above 25,000. The P-38 hit its stride there. Speed let it choose when to fight and when to leave. Mock fights exposed the power of nose-mounted guns. Italian wing guns had to be harmonized for a fixed range, typically 300 meters, and were weaker at others. The Lightning's battery needed no convergence. You simply aimed. More unsettling were the teardown findings. Build quality bordered on obsessive. Welds were uniform. Machining exact. Materials top grade throughout. No shortcuts. No desperate substitutions. no hint of scarcity. One engineer wrote, "Everything is built to a safety margin we cannot afford." Where Italian designs chase the ragged edge of minimal material, the American approach achieved performance with superior material and manufacturing and added margin. The structure carried more weight than the bare minimum, buying durability and damage tolerance. The electrical system had extra breakers and redundancy Italian designers would never specify. Hydraulic lines wore armor that cost weight but paid survivability. It was engineering from a country acting like resources were infinite, and it worked. The P-38's famous toughness wasn't luck. It was baked in. Zapata's report went up the chain. Manufacturers received the technical digest with orders to harvest anything they could adopt. The strategic section landed on the desk of Generale Mario Dell'Aria, known in the service as the capo of the air arm, who read it, then filed it away. There was nothing actionable. Italy lacked the industrial base to copy American technology. German help was consumed by German priorities. The best Italian minds could do was tune existing types and hope pilot skill and clever tactics bridged a widening gap. It wouldn't. On August 11, 1943, Tandi took the captured Lightning into combat. Intelligence reported B-24 liberators straggling home from the tourney raid. Tandi launched from Guidonia, climbed and slid into position, his silhouette trusted by the Americans below. He opened on a lagging bomber, cannon, and 450s ripped into the Liberator. He claimed the kill, possibly Bonnie Sue or Lady Evelyn. Records disagree. A small victory. A captured American fighter flown by Italy's finest shot down one American bomber. Good propaganda. Strategically meaningless. Soon after, the Lightning was grounded. No spares, no manuals, no logistical web like the one that kept U.S. P-38s flying. The captive fighter became a hangar queen. Tandi never flew it again. The war moved on. Italy capitulated in September 1943. The Guidonia P-38 passed to German hands, then was destroyed to prevent recapture. Zapata's report survived in the archives, a technical timestamp on the moment Italian engineers measured American industrial might and had no reply. Post-war production data, once declassified, showed Zapata had been conservative. The United States built about 10 out of 37 P-38s of all marks. Each carried 2 Allison V-1710s, over 20,000 engines for the Lightning alone. The V-1710 also powered P-40s, P-39s, and P-63s. Total output topped 70,000. Italy's entire wartime engine production, all firms combined, hovered around 13,000. America had made 5 times that number of a single advanced type. The gap showed up everywhere else, too. The U.S. produced over 300,000 aircraft in the war. Italy, roughly 11,000. In 1943 alone, American aluminum output exceeded Italy's total wartime production. U.S. factory workers, many of them women new to the trade, assembled complex aircraft with a consistency Italian craftsmen could not match under siege. In the 1960s, an Italian aviation historian interviewed the retired Zapata about that June inspection. He chose his words carefully. "I knew we would lose when I lifted those cowlings," he said. "Not because of one part, but because of what the whole machine signified. The Americans built a fighter that needed 50,000 parts, including 2 of the most complicated engines in service, and they were producing them in numbers we couldn't reach even with our simplest designs. When I ran the man-hours, the materials, the precision, the quality control required, it was obvious. We were fighting an industrial giant barely warmed up. The P-38 wasn't even their best. It was one of several advanced types built at the same time. We strained to make 100 fighters in a month. They made thousands, each as good as, or better than, our finest. "Did you ever fly a P-38?" the historian asked. Zapata smiled. Tandi offered. I declined. "I'm an engineer, not a pilot. I didn't need to fly it. The figures told the story: power to weight, wing loading, thrust available versus required. The math of flight is merciless. The P-38 had more power, altitude, firepower, range, and better systems. It was superior, and there were thousands." The captured P-38G at Guidonia never enjoyed long service. It flew a few trials, joined one combat, then sat as a curiosity, evidence of a war already lost, studied by engineers who grasped the meaning but could not change the outcome. In the end, the Lightning's Italian chapter is a study in industrial scale and the arithmetic of modern war. Italy entered with gifted designers, brave pilots, and a proud tradition, but without the industrial infrastructure to compete with American mass production, without the resources to mature technologies like practical turbocharging, without the materials to build with American safety margins, and without time to close a gap widening by the month. Zapata's report set it down in plain engineering terms. 2 Allison V-1710s producing roughly 2,250 combined horsepower. Turbochargers holding sea-level power near 25,000 feet. Counter-rotating props canceling torque. Nose-mounted guns with 2,000 rounds. System integration and redundancy that favored effectiveness over weight savings. And behind all of it, an industrial engine that could produce such complexity at rates that made Italian production look trivial. The Lightning sat on that Guidonia ramp only a few months, but for the engineers who measured it and did the math, it marked a turning point, the moment arithmetic crushed optimism, and they understood this war would be decided not by daring or skill, but by factories, resources, and capacity. America had them all. Italy did not. The Lightning proved it, and no amount of Italian ingenuity could undo that fact.